just like we have with exponents, we have properties of exponents, and we also have properties of logs. So through this section, we're going to cover, starting with just the first one, and we're going to talk about just the product rule of logs. Now, to kind of refresh our memory, the product rule of exponents deals with what happens with product. Of course, we know means multiplication. We know that if we multiply with the same base, we add the exponents. So that's kind of a similar idea that we have with properties of logs as well. So we should be pretty familiar with the properties of exponents, and especially the product rule, but we've reviewed it here. When we multiply, we add. Now, if you look at the product rule for logs, now since exponents and logs, which not exponents, there's a difference between just an exponent and an exponential function, but we've been dealing with converting from a log form to an exponential form. So if we think about that, and we're looking at these properties of exponents, it's very similar for the product rule of logs. If you have the log, and what you're taking out the log of is being multiplied. So I have a log with a base, and I'm taking the log of an m times an n. We can use the product rule of logs and expand that into an addition. So you can see when we multiply with exponents, we add. When we have multiplication with logs, we also add. So they're very, very similar, and they correspond to each other. So what we're doing is, and this is very similar to also, you can look at it as kind of factoring and distributing. For instance, if I have, say, 8 times x minus 2, now we would say that this is factored. If I multiply that back out, we know that this is 8x minus 16. But we also know that these are equivalent, that 8 times x minus 2 and 8x minus 16 are the exact same thing. It's just one of them is factored and one of them is not. There are times when we know sometimes we need it to be factored and sometimes we need to expand it out. And it's very similar with properties of logs as well. Sometimes we need it condensed, or in what we would consider a factored form. Sometimes we need it expanded all the way out so we can look at everything. And that's where the product rule comes in. So just to start off with the basics and learning how to use this product rule, all we're going to do here is the directions say expand each log. So we're going to expand the log, and we have here for a natural log of 7x. So what I'm taking the log of is a product. That is 7 times x. So again, it's almost like you're distributing. So basically, we can look at this as this log is going to the 7, and that log is going to go to that x. But because this is being multiplied, when we expand this out, we expand that out to a subtraction. Okay, so that's all the basics of the product rule of logs consist of, is just rewriting it in an equivalent form. Now, we could plug this into our calculator and it would give us a decimal, but we do not want a decimal answer here. We want to leave it as it is. Okay? Alright, for example B, we have log of 10x. Now, one thing we should be able to recognize here is if there's no base here, we know that there's actually a base of 10 right there. That's our common log. But we'll leave it as it is for right now. So this is 10 times x, which means we're going to expand this log. So the log goes to the 10, and the log goes to that x. And because it was a product, we know that we add in between, because the product rule says if you're going to expand it, if it's multiplication, it expands to addition. Now, one thing that's different on this one that we didn't have on example A is log is actually base 10. So this is actually log base 10 of 10. Now this is different than the first one because the natural log of 7 up there would give me a decimal. We don't want a decimal answer. But this is where our basic properties come in. We should hopefully be able to recognize that log base 10 of 10 is, in other words, log base b of b, which is actually equal to just 1. So that's actually one of the purposes we have for expanding, is we can maybe try to simplify this down a little bit. And in this case we could. When we expanded it, we were able to actually evaluate part of the log. Okay, so that's all the product rule consists of. The second property of log that we're going to deal with is the quotient rule. And again, to kind of refer back to the quotient rule of exponents, the quotient rule of exponents says that when we divide, since quotient means divide, we subtract those exponents. And this is also similar to the quotient rule of logs. If you have a log, and that log in that base is going to a quotient, is going to a fraction, when we expand that out, it expands out to subtraction. So very similar, and you can see why we kind of relate these together, because when you divide, you subtract the exponents. With logs, when you divide, you subtract the logs. Okay? And again, all this, the other stuff up here, let b, m, and n be positive real numbers. We know that b can't be equal to 1. Alright, so we've got, because our base can't be equal to 1, we define that back in when we first defined just exponentials in general. So example 2, using the quotient rule. All I want to do here is expand. So we've got the log base on the outside. So the log is actually going to go to the numerator. So we know that this log base 5 is going to go to the 125. And we also know that that log base 5 goes to the y. Because it was division, the rule says that we subtract. And that's all we have to do to expand that out. Now, one thing we do need to look at or take into consideration is, can I figure out, or is this equal to a number? So let's check this. What is log base 5 of 125 equal to? So we're going to set this equal to a y so that we can get it out of log form and into exponential form to see if we can finish working this out. And we can. 5 to what power gives me 125? And of course the answer there is 3. So log base 5 of 25 is actually equal to 3, so we're going to simplify that even further into 3 minus log base 5 of y. Okay, so that's all the quotient rule of logs consists of. And then the last rule that we have is the power rule. And just like we have the power rule of exponents, and it's not as relatable as the quotient rule and the product rule that we've seen, but again, to kind of refresh our memory, the power rule says if you got a power raised to a power, we multiply. Well, it's slightly different. In a way, it's a slightly different rule with the power rule of logs, but it says if you're taking the log of a number, and that number, what you're taking the log of, has this exponent up here, has that p, that is actually the same thing as bringing that exponent out front and multiplying it by the log. And that's where, again, you can kind of see the relation, because the power rule here deals with you multiply those exponents. And this one here, it's the similarity here is you're taking that exponent and you're multiplying it by the entire log. And those are actually equivalent logs. So that's our idea of expanding out the log with a power rule. So one quick example here for the product rule is if I have log base b of x cubed, if all I want to do to expand that is the 3 comes out front, and this becomes 3 times log base b of x. And that's all we have to do to expand out our power rule.